Welcome to The Explainer. Today we're going to talk about something pretty incredible. How drones are learning to see sickness in a way that we humans just can't. It's kind of like giving them X-ray vision for crops to help protect one of the most important foods on the planet.
So, let's start with a number. 50%. That is the potential crop loss that just a single disease can cause in rice paddies. Now think about that. For a crop that's a staple for billions of people, that number isn't just a statistic, it's a massive threat to our global food security.
So why is that 50% figure so scary? Well, to really get it, you have to understand the sheer scale of rice farming. This isn't just about what you might have for dinner tonight. We're talking about the very foundation of entire economies and societies.
I mean, rice isn't just a side dish, right? It's a cornerstone of global agriculture. Take a country like Indonesia, one of the world's top producers. In 2023, they harvested over 54 million tons. So it's way more than just food. It's this massive economic engine that provides jobs for millions and millions of people.
But here's the problem. This incredibly important crop has a major enemy, a devastating disease that ironically loves the exact same warm, wet conditions that rice needs to grow. So farmers are in this constant uphill battle.
And here's our villain, bacterial leaf blight, or BLB for short. What it does is, it basically attacks the leaves, creating these lesions that stop the plant from photosynthesizing, making its own food. It completely cripples the plant, and then it just spreads like wildfire through an entire field.
So, for years, how did we fight this? Well, the only way was to send out experts. They call them pest observers, to literally walk through the fields and inspect plants one by one. I mean, you can imagine it's super slow, it's exhausting, and let's be honest, it's pretty subjective. One person's kind of sick is another's really sick. And you just can't cover huge areas fast enough, which means the data you get is often just a generalization. That's a huge problem when you're trying to make fair decisions about something like crop insurance.
Okay, so that brings us to the big question, right? If the old way is too slow and too subjective, how in the world can we get a faster, more accurate picture of what's happening with this disease before it's too late?
So you're probably thinking, just use a drone. Fly over, snap a picture, problem solved. But it's not that simple. The issue isn't really the camera, it's the pixels themselves. A regular photo can only tell you so much. See, it's not just about spotting sick plants. It's about understanding how the sickness is moving and behaving across the whole field.
And this is where things get really cool. Check out this comparison. The old way of analyzing this stuff is pixel-based. It looks at a field as just a collection of millions of tiny individual dots. But that can be misleading, right? A single pixel might have a bit of a healthy plant and a bit of a sick one. It has no context. The new way, this innovative approach, is patch-based. It's way smarter. It groups those pixels together into meaningful shapes. It actually sees the pattern of the disease, treating a whole cluster of sick plants as one object.
So this new method is called patch fragmentation analysis. And honestly, the best way to think about it is like being a detective for plant disease. It's not just pointing and saying that plant is sick. No, it analyzes the whole scene. How is the disease spreading? Where is it clumping up? What kind of patterns is it making? It's so much more sophisticated.
Okay, so how does this whole high-tech system actually work? It's basically a 5-step process. First, you've got a special multispectral drone that flies over and captures data our eyes can't see. Step 2, that data is turned into these health maps that show where the plants are stressed. Then an algorithm comes in and isolates all the problem spots, creating a simple black and white map: sick areas and healthy areas. Now, step 4 is where the magic really happens. The software analyzes the patterns of those sick patches, their size, their shape, how they're connected. And finally, a machine learning model takes all that pattern data and spits out a super precise classification of how severe the disease is.
So it all comes down to this one core idea. It's not just about what's sick, but how it's sick. The way the disease spreads and clumps together, its spatial pattern, that tells you a much richer story than just counting up individual sick plants.
And the results? I mean, they're just staggering. This new patch-based method was able to tell the difference between different levels of disease with, get this, nearly 94% accuracy. That is a huge leap forward.
Okay, so we have this super high-tech, 94% accurate solution. What does that actually mean for the people on the ground? For the farmers, for the insurance companies, and really, for all of us who depend on this food? Well, the payoff is absolutely massive.
And this table just lays it out so clearly.
Look at this. An area that used to take a team of experts 10, even 11 days to check by hand, this new drone method gets it done in a day and a half. That's saving over a week of hard labor for just one section of farmland. That's incredible.
So you can see why this matters so much. For farmers, it means much fairer crop insurance, because the payments are based on real, precise data, not just some rough guess. For the authorities, it means they can jump on an outbreak way faster. It saves a ton of money and time. But the bottom line is this: it helps us protect a critical global food source more effectively, and that improves food security for everyone.
And that leaves us with a really interesting final thought. We've basically taught technology how to see the invisible landscape of a disease from the sky. It really makes you wonder, right? What other hidden threats, maybe to our forests or our oceans or our climate, what else could we start to uncover now that we know how to look for the patterns?